Hey folks, and welcome to our next lesson in Unit 9, the Cartesian plane. Today we're going to be talking about parallel and perpendicular slopes. Now, this was kind of a pain when we did it with proofs. There are no proofs in this lesson, and the Cartesian plane makes it a lot easier. Let's take a look at parallel lines first. So our aim today is to determine how the equations of parallel and perpendicular lines are related. Now, we've talked about parallel and perpendicular lines off of the xy plane before. On the xy plane, they have a really nice relationship. So what I'm going to do first is we're going to draw two parallel lines, and we're going to discover something about their equations. Okay, so within human error, these lines are parallel. What I'm going to do now is find their equations, and we're going to do it in slope-intercept form. You've seen it before. It's y equals mx plus b. Nice little blast from the past. Remember, m here is the slope, and b here is the y-intercept. So let's take a look at this. This top line, the first one that I drew, well, its slope is up 1 over 2. Because from here, it goes up 1 and then over 2 points. So this is equal to y equals up 1 over 2, a half, x, and it intercepts at 1. Now this one, let's see what it has. It also goes up 1 and over 2. So it also has the slope of 1/2, plus, and its y-intercept here is 0. You can add plus 0, or you can just say it's just equal to 1/2 x. Now, the thing that's always going to be true about parallel lines is their slope will be the same every single time. Their slope will always be the same. So this would be an important thing to write in. Parallel lines have the same slope. Notice they had different y-intercepts, and that's always going to be the case. If it has the same slope and the same y-intercept, well then it's the same line. But you can determine if two lines are parallel by if they have the same slope. Cool. So parallel lines always have the same slope. It doesn't matter if the slope is positive, negative, fraction, whole number, they're always the same slope. Now, we didn't really care about the y-intercept here. That's because you have many parallel lines to any first line. If, however, two lines have the same slope and the y-intercept, well, it turns out they're not the two lines, they're actually the exact same. If you had one line that was y equals negative 3x plus 2 and another line that was negative 3x plus 2, they're the same line, they exist in the same place. Enough about parallel lines, let's take a look at perpendicular. Now, remember, two lines are perpendicular if they intersect at a right angle. Now, we already have a line drawn here, and its equation is y equals 1/3 x plus 2. The plus 2 comes from the y-intercept, the 1/3 comes from the fact that it rises 1 and runs 3, to this point right here. Now, we want to make a line which is perpendicular to it, intersects at a right angle. So I'm going to take my ruler, I'm going to line it up. Now, there are a lot of lines which can do it. This is just one of them. So if I look right here and draw this line, well, that intersects at a right angle. Let's figure out the equation of this line now. Well, its y-intercept up here is at 3, so I know it's going to be y equals, I'm going to leave the slope blank for a second, plus 3. Its slope here is clearly negative. It's going down. Now let's count the rise over run. It goes from here, 1, 2, 3 down, and 1 over. So it's negative 3 over 1. And we can just rewrite this as y equals negative 3x plus 3. Let's look at the slopes. The slopes are the important part with the parallel lines. They're the important part here too. We're going to compare this slope to this slope. And this one, it's the same thing. Turns out that perpendicular lines have negative reciprocal slopes. Now that's just a fancy way of saying two things happened here. That has to happen when we're talking about negative reciprocal slopes. because we have two words going on here that mean two different things. The negative part is talking about the signs, and the reciprocal part is talking about the fraction. Both of those have to happen for us to have perpendicular slopes. So that was perpendicular lines. You have negative reciprocal slopes. Two things have to happen here. First, they have to be negative, so the sign just has to flip. Doesn't matter if the end result is positive or negative, as long as it's the opposite of the first one. Second is the fraction has to flip. Whatever was on the top is now on the bottom, whatever was on the bottom is now on the top. That's the reciprocal part. Now, let's take a look at how these will pop up in examples. They don't always look like slope-intercept form, but we can easily make them slope-intercept form through some algebra. Let's take a look. So this is a pretty standard example. Write the equation of a line parallel to this. Now obviously this equation is not in slope-intercept form. It's not y equals mx plus b. This is actually in standard form. You've seen it before in Algebra 1. Now, in order to figure out a line parallel, we know that parallel means that the slope has to be the same. The y-intercept can be anything. The slope has to be the same. So first, I need to figure out the slope here. And I'm going to do it by isolating y and making it into y equals mx plus b form. First thing is I'm going to move over the 3x. I subtracted 3x from both sides. Here it canceled. Here, it's just negative 3x. Next, I'm just going to divide by 8. So, if I divide everything by 8, 40 over 8, and now 40 over 8 I can reduce a little bit. So, my slope, my m here, is whatever value is next to x. So negative 3 over 8. I can make an equation parallel to my original equation by just including that slope. It doesn't matter what the y-intercept is. So long as it has that slope, it's going to be parallel to my original equation. So you can pick any number in the world that you'd like. So long as it has that same slope, you're good. This is the equation of a line parallel to the original, because the original has a slope of negative 3 over 8, and this new one also has a slope of negative 3 over 8. Let's take a look at one of these with a perpendicular equation. So here we have our second example, writing the equation of a line perpendicular to a given equation. Now remember, perpendicular means that we have a negative reciprocal slope. So whatever slope I find for the original, I need to do two things. First flip its fraction, and then flip its sign. The beginning, though, is still going to be the exact same. I need to get y by itself here. So I'm going to subtract over the 5x. Cool, now it's looking even closer to y equals mx plus b form. Now I just need to divide by 2 to get y by itself. We can reduce that a little bit. We can get negative 5 over 2x plus 4. Now, the slope is going to be the negative reciprocal. So I need to do two things. First off, this slope is already a negative, so I need to make it a positive. So it's going to be positive. Second, I need to flip my fraction. So instead of 5 over 2, it's going to be 2 over 5. And this is the slope of any line perpendicular to my original equation. Again, the y-intercept doesn't matter here because it doesn't specify anything. It just says a line, not a specific line. So I'm going to write y equals 2 over 5x plus, 7 billion. Because this line's slope is the negative reciprocal of this slope, it's a flipped fraction, and it's negative instead of positive, we're good. These two lines are going to be perpendicular. Cool. So that's all well and good, but how will it appear if you're comparing two lines that you don't know? Well, let's take a look. You have 4 options here. Lines can either be parallel, perpendicular, neither, or they're the exact same line. Really, the first three options are a lot more common. The last one is a once in the blue moon thing. Let's take a look. So, our last two examples. We're going to determine if the lines are parallel, perpendicular, or neither. Parallel means the same slope, perpendicular means negative reciprocal slopes, and neither are any two slopes otherwise. Let's take a look. So, here we have these two examples. You might want to pause the video and write them in. If we look at their two slopes, we see that we have a slope of 2 and a slope of positive 1/2. Clearly they're not the same, so parallel is not an option. However, both of them are positive. Even though the fractions are flipped, they're not negative reciprocals, they're just reciprocals. So these are neither. Cool, let's take a look at the next one. Clearly here, these are not in y equals mx plus b form, so it would be really helpful to write them in y equals mx plus b form. For the sake of time, I'm just going to write out the algebra here. Now, if we look at their slopes, well, this has a slope of -4, this has a slope of -4. So our answers are that they are parallel. And the reason is the slopes are the same. Cool. So now you have seen parallel and perpendicular lines. You can determine if two lines are parallel or perpendicular, and you can find the slope. Give delta math a shot. Now notice throughout all of today, we're really just worrying about the slope. We're not worrying so much about the y-intercept. In our next lesson, we're going to talk about the y-intercept a bit more, but not today. Stay safe, folks, and I'll talk at you soon.